Hey everybody, today we're going to focus on something that is called systems of linear equations. So remember, we have already discussed linear equations earlier in the year, and right before break we referenced it a bit as well. Remember, the form we've been using is y equals mx plus b. Remember, m is your slope or your rate, and b is your y-intercept. Remember, if something is linear, when you graph it, it will always have a straight line. So we could write that, a straight line when graphed. And it always has a constant rate. So this form down here is called slope-intercept form because we have our slope and our y-intercept. The other form we discussed earlier in the year was something that looked like this: ax plus by equals c, and this is called the standard form. So remember, sorry, that's Maverick if you heard him. So like I said, we always are going to make sure we have it in the slope-intercept form, the y equals mx plus b. If I give it to you in this form, the standard form, remember at the very beginning of the school year we learned to solve for y, to get y by itself, which we'll practice in this little lesson as well. So you should have your notes packet in front of you, and we're just going to go over some vocabulary. A system of a linear equation is basically two or more linear equations. Alright, so as you can see here, I typed in this information just so you can see it a little bit better. A solution of a system of a linear equation is basically a coordinate point that satisfies both equations at the same time. It's basically your point of intersection, or sometimes abbreviated as POI. So like I said, this right here is basically your intersection point. So if I had my two lines, let's say those are my two lines, right here my dot in yellow is my solution to the system, which is also known as your intersection point. If you have no solution, which we have down here, the lines do not have a common intersection point. Therefore, these lines will always be parallel. So if I was graphing two systems of linear equations, if I graph them, I would have parallel lines. They would never intersect. And lastly, a system of an equation has infinitely many solutions when the equations are exactly the same. So if I graphed one line, and if I wanted to graph the other line, it's literally going to be exactly on top of it. It's the same equation. So let's just summarize that a bit more. So basically, when you solve systems, you're going to have three different cases. One case is the lines will intersect. So there is always one solution when your lines intersect, which would be right here in this point, because that's where they cross or intersect. This will always happen when they have different slopes. Another case is when they have the same slope but different y-intercepts. This time the lines are going to be parallel, so there are no solutions, because as you can see here, these lines never cross, so there's never an intersection point. The last case is when they have the same slope and the same y-intercept. This would mean they're exactly the same equation. The lines are equal, so there are infinitely many. So what we're going to do now, we're going to go through a few examples. Sometimes I will graph it and you'll be able to see if there's one no solution, or infinitely many, or sometimes we will actually solve the system. So let's take a look at the next page. So this is an example of a system with no solution. So what we're going to do first is set our two equations. You always set your two equations equal. So I have 3x plus 2. I'm going to set it equal to my other equation, 3x minus 2. So remember, when you have variables on both sides, you're going to get rid of one of them. But oh wow, they're both 3. So if I would subtract 3x from both sides, these would cancel. I'm left with 2 is equal to negative 2. In your life, does 2 ever equal negative 2? No. That's why there's no solution here. You would also could tell just by looking at this equation because they have the same slope but different y-intercepts. Now if we would graph this, so remember my two equations are y equals 3x plus 2 and my other equation is y equals 3x minus 2. So let's say on the PSSAs you forget how to solve the equations up here to determine if it was 1, none, or infinite. You could always graph it. So let's graph this first equation. First thing I'm going to do is plot my y-intercept, which is at positive 2. So I'm going to plot my y-intercept. Next thing I'm going to do is look at my slope. My slope is 3. Remember, if your slope is just a whole number, put it over 1, and that would be equal to your rise over your run. So from my y-intercept right here, I'm going to rise 1, 2, 3, and run 1, and I'll plot my point right here. Going to do that again, rise 1, 2, 3, run 1, plot my point. We did this earlier in the year. Remember the opposite of up 3, right 1, you could go down 3, left 1, and plot your point. Same thing, go down 3, left 1, down 3, left 1, and so forth. You would have a line, it's hard for me to draw a straight line on here that looks something like that. Next thing you could do is graph your next one. So here my y-intercept is at negative 2. However, my slope is still 3. So remember, if it's not in fraction form, put it over 1 so you know what to rise and what to run. So from my y-intercept, I'm going to go up 3, right 1, plot it. Up 3, right 1, plot it. Up 3, right 1, plot it. And remember, I can do the opposite. I can go down 3, left 1, and plot it. Let's do that again. Down 3, left 1, and plot it. So like I said, on your PSSAs, if you forget how to solve using the equation method, you could always graph them. And do you see how they're parallel lines? They never intersect, therefore it is no solution. Okay, this example is when we have a system with infinitely many solutions. With this example, they have the same slope. My slope is negative 3/4 in both of them. They also have the same y-intercept. Therefore, since it is the same slope, the same y-intercept, they are both the same equation. Therefore, the answer to this would be infinitely many solutions, because it is the same exact line. What is on one equation would be on the other because it's the exact same line. If we wanted to plot this and see this in action, we could. So my y-intercept is at positive 3, so I'm going to plot that. My slope is right there, and it's at negative 3/4. Remember, it does not matter which value you put the negative sign with. And remember, this is already a fraction, so I don't have to put it over 1. So I have my rise and my run. So from this point, I could go down 3, right 4. And I plot my point. The opposite of going down 3, right 4 would be going up 3, left 4, and plot my point. And here's my beautiful line. So I just graphed this one, but as you can see, the one above it has the exact same slope and y-intercepts. It would literally be the same exact data values. So if you have the same equation, your line is exactly the same and you will have infinitely many solutions. Alright, so for this one, this is an example when the system has exactly one solution, therefore there should be an intersection point. First thing I'm going to show you to do is solve it by using your equations. So this one is already set for y equals. This one below is not. So the first thing I have to do is change this from standard form to slope-intercept form, which basically means we need to solve for y. We need to get y by itself. So if here's my equation, 2x plus 4y equals 12. I need to get y by itself. So the first thing I'm going to do is subtract 2x from both sides. Those cancel. So I have 4y equals 12 minus 2x. Remember, we cannot combine the 12 and the 2x because this has a variable and this does not. To get y by itself, the opposite of multiplying by 4 would be dividing every single term by 4. When I do that, I would be left with y equals 12 divided by 4 is 3, 2 minus 4 is 2/4 or 1/2 x. So now I have my equation in slope-intercept form, so I can set them both equal. So my first equation was 2 minus x equals my equation 3 minus 1/2 x. Remember, I need to get all of my variables to one side. So the first thing, it doesn't matter. Remember, you can put a 1 out in front of here if you don't remember that it's always a 1. So the first thing I might do is add 1x to both sides. These would cancel, and I'm left with 2 equals 3 plus 0.5x. I'm going to subtract 3 from both sides. So I would have negative 1 equals 0.5x, and the opposite of multiplying by 0.5 would be dividing by 0.5. And I would have negative 2 is equal to x. So that is the solution. When x is negative 2, that's where my intersection point would be. However, you're not necessarily done yet. The question might ask you to find your ordered pair, and you could do that by plugging in this x value into either equation to find your y value, or you could graph it, which I'm going to show you that method right now. So I'm going to erase all this other information just so we can see the graph. So remember, one of my equations was right here in purple, y equals 2 minus x. So the first thing I'm going to do is plot my y-intercept. So I have y equals 2 minus x. So my y-intercept of this equation is 2. My slope of this equation is negative 1. Remember, if it's not in fraction form, put it over 1 so we know what our rise and our run would be. So for my y-intercept, I'm going to go down 1, right 1. I'm going to keep on doing that. Down 1, right 1, plot. Down 1, right 1, plot. Down 1, right 1, plot. and you're going to keep on doing this until you literally run out of room. The opposite of going down one, right one would be up one, left one. And remember, if you are doing this absolutely correct, you would have a straight line when you graphed it. Now, to get the other equation, remember we already solved it in the y equals form, so it was y equals 3 minus 1/2 x. My y-intercept is positive 3. My slope is negative 1/2. So the first thing I'm going to do is plot my y-intercept at positive 3, and then I'm going to use my rise and my run. So for my y-intercept, I'm going to go down 1, right 2, and plot it. Down 1, right 2, and so forth. Remember, the opposite of going down 1, right 2 would be going up 1, left 2. Plot it. Up 1, left 2. If you did this correctly, you would have a line like this, and oh my goodness, here's my point of intersection, which is also my solution. There's one solution here. So my solution would be the ordered pair negative 2, 4. And there is only one solution. Okay, so this page is just to summarize a little bit what we just talked about. Remember, there are 3 different scenarios you could have. You can have one solution, no solution, or infinitely many solutions. This right here would have one solution because you have an intersection point. The second case would be no solution because your lines are parallel. The third solution would be infinitely many because it's the exact same line. So please remember those scenarios. So for these next few examples, I'm going to do some with you, and then I'm going to have you try some on your own. You could either graph them or solve them algebraically. The easiest way would be to solve them algebraically, and you are going to tell me if there's one solution, no solution, or infinitely many. So let's start to do the first one. Since they are both set for y equals, we can put them both equal to each other. So I have x plus 2 equals 2x plus 1. I'm going to get x to one side, so I'm going to subtract x from both sides. These cancel, and I'm left with 2 is equal to 1x plus 1. I'll subtract 1 from both sides. Remember, this is exactly what we did at the beginning of the year. So I have 1 equals 1x. And the opposite of multiplying by 1 would be dividing by 1. So in this case, 1 is equal to x. Since it gave me one solution for x, my answer for this would be one solution. And as you can see below, I graphed it as well. In yellow is my intersection point, which shows me I have one solution, and it was at the ordered pair 1, 3. I want you to try B on your own, and then you can press play, pause the video and press play when you have your answer. Okay, if you did this one correctly, your final answer should have been one solution, because when it was all said and done and I solved, I actually got a value for x. 2 is equal to x. I also, when I graphed them, you can see I had an intersection point, and that's what makes it be one solution, which is at the ordered pair 2, -2. So this one's a little bit different. It says x equals 2, y equals -6. I just threw this one in here for you to see, and all we're going to do is graph it. So it tells me to graph the line when x is equal to 2. So this is the point where you guys kind of get confused, but remember, here's my x-axis when it's 2, and I'm just going to keep on extending my line. Then I'm also going to graph the line y equals -6, which here's when y is -6. and I'm just going to extend my line. Here I go. My lines intersect. Therefore, I have one solution. Why don't you try D on your own and see if you have one, infinite, or no solutions? Hopefully you got the answer of one solution because you have an intersection point. So I'm going to do E with you. For E, first thing I'm going to do is solve this. So I'm going to actually put it underneath so I have more room. So my two equations were, remember all you do is set them equal, 2x minus 6 is equal to 3 minus x. We're going to start solving. So I need to get one of my x's to the other side by doing the opposite operation. So I would have 3x minus 6 equals 3. I'm going to add 6 to both sides to give me 3x equals 9. The opposite of multiplying by 3 would be dividing by 3. So in this case, x equals 3. Since it equals a specific value, your final answer would be one solution. If you would have graphed these, which I'm not going to do, but if you would graph them, actually I'll graph them for you. As you can see, I have one intersection point. That's why it is one solution. Why don't you try to do F on your own, and you can check your answers with mine to see if it's one, none, or infinite. So your answer for F, whether you graphed it or hopefully you're doing the algebraic way, should be one solution because you had a clear value what x was equal to, and when you graphed it you had one intersection point. Okay, for this one, we only have one of them in slope-intercept form. We have to make this one into slope-intercept form in order to solve them. So the first thing we need to do is solve for y. So I have 3x plus 4y equals 12. I'm going to get y by itself. So I'm going to subtract 3x from both sides. These cancel. So I have 4y equals 12 minus 3x. Now I'm going to divide every single term by 4 to get y by itself. So when that's all said and done, I would have y equals 12 divided by 4 is 3 minus 3/4 x. So now I have both of my equations set equal for y, and now I can put them both together and solve. So my one equation up top right here is y equals negative 3/4 x plus 3. Whoops, let me fix that a bit. And I also have this equation down here, which I'll write in yellow, y equals 3 minus 3/4 x. So the first thing I'm going to do is set them equal to each other. Negative 3/4 x plus 3 equals 3 minus 3/4 x. Let's start solving. So the first thing I'm going to do is start to add 3/4 x to both sides. Those cancel, so I'm left with 3 is equal to 3. Oh wow, these are the exact same value, so they're going to cancel as well. Do you see here how I have the same value, 3 equals 3? Also, you could have checked from the very beginning. Negative 3/4 is my slope in this problem, and it is also my slope in that problem. 3 is my y-intercept in that equation, and 3 is my y-intercept in this equation. So when you have the same slopes and same y-intercepts, your answer would be infinitely many. Because no matter what, if you graph this, you would have the same exact line. And I graphed it. I know my line's not the best, but this purple line would be both equations because it's the same exact line. Alright, let's try this one. First thing, they're both in the y equals, the y-intercept form, so I'm going to set them equal to one another. 3/5 x is equal to 3/5 x minus 2. Let's start solving. So I'm going to get the x's to one side, and some of you might already be seeing what I'm about to tell you. these cancel, and these cancel. So literally you have nothing on this side, and you have -2 on this side. Does 0 equal to -2? No, they're two different values. So in this case, you would have no solution. And if you graph them, you would see this. They never intersect. They're not the same line. They are parallel. That is why it is no solution. Why don't you try this last one on your own, and when you're ready to check your answer, you may press play. For this next one, your answer should have been no solution. The first thing you had to do is solve to get y by itself for that second equation, which I did right here. I subtracted 6x from both sides, and then I divided every single term by -4 to give me y equals 1/4 plus 3/2 x. Once I had that, I put this equation and my first equation, and I set them equal to one another. And then I solve to get x by itself. But when I do that, my x's basically canceled out. I had nothing on this side. That's why if 0 is equal to just your 1/4. Since those values are not equal, there is no solution. And I'm not going to graph this, but if I would have graphed it, you would have had parallel lines. Okay, just a quick little recap. Remember, if you have one solution, you are going to have different slopes. There will be an intersection point. And when you're doing this, if you're always in that y equals mx plus b form, you could just look at your slopes. If your slopes are different, you know it will always have one solution. If there's no solution, you would have the same slope and different y-intercepts. Your lines will always be parallel. They will never intersect. That's why you have no solution in common. Lastly, if you have infinitely many, you would have the same slope and the same y-intercept. Therefore, it is the same exact line. Therefore, every single solution is the same because it's the same line. Your homework would be to finish the rest of the packet, which are just a few questions. I would prefer you to solve these algebraically, and then you could graph them just to confirm your answer. So you only have a few questions. You only have about 9 questions. That is it. So make sure you have this done. It is worth points for tomorrow. And as always, tomorrow you can ask me for help or ask your peers around you or ask Mr. Kate. Thank you so much and have a wonderful day.